The question we're going to tackle now is what is the concentration of lead ions and what is the concentration of chromate ions if KSP of lead to chromate is 1.8 times 10 to the negative 14th. So let's imagine we take some lead to chromate, put it in some water. So this is a solid, it's an ionic compound. It's going to dissociate into Pb2 plus ions and CrO4 minus ions. These guys are going to be aqueous, and that's sort of implied by the ion value, but we'll be very explicit here. So just like any equilibrium, we are going to say that K is going to equal the concentration of the products times the so multiplied together over the concentration of the reactants. But since the reactants here are a solid, it's just going to be over an understood 1. And then since this is for a dissolving process rather than a reaction, that's why KSP, or we call it KSP, so SP for solubility product. But it's no different than reaction quotient or KEQ. So it's just to designate that this is for the dissolving of an ionic compound. Now what I want to find is what the concentration of the lead ions and the chromate ions would be given that KSP equals 1.8 times 10 to the negative 14th. So I have two variables here that I have to try and solve for, but they are going to occur at the exact same ratio, right? If X amount of lead to chromate dissolves, I'm going to end up with X number of lead ions and X number of chromate ions. It's impossible to make one of these without also making the other. So really what I have is KSP equals two numbers that are the same multiplied together, and what I'm going to do is sub in X squared for that. So we're going to say X squared, and it's over 1, but we'll drop that over 1 thing to make it look a little prettier. So here, let's even move our, that's ugly. So we will just sub in X squared for our concentrations, and that's going to equal our KSP value of 1.8 times 10 to the negative 14th. So if I want to know just X, I will take the square root of both sides. Can you even tell that that was a different color? I don't think so. And the square root of 1.8 times 10 to the negative 14th is 2 sig figs. So it'd be 1.3 times 10 to the minus 7. So X equals 1.3 times 10 to the minus 7th. And that's actually going to be our answer because KSP, the X is actually equal our answer. So that would be the concentration, and that would be moles per liter, or you could say molar, lead ions and chromate ions.